All right, so additional topic number 7 is on ellipses and hyperbolas. You can call it ellipses, that's also a correct pronunciation, and hyperbolas. All right, so like I said, we're going to kind of skip around. The main thing I want you guys to know about an ellipse and a hyperbola is how to graph them. Okay, so you might want to like go to that blank page in your notes, and we'll just do a couple examples of just graphing, okay? Or if there's any room anywhere. Okay, so here's what an ellipse is going to look like. Okay, let's say I have x squared over 16 plus y squared over 25 equals 1. Okay, it's always in the form, well, let's make it a little bit harder. Let's say y squared, or y minus 2 squared over 25 equals 1. Okay, it's always going to be in the form where you have x minus h squared, you have y minus k squared, they're both going to be over something squared equals 1. Okay, what do you guys think hk is going to be? What has it been before? What was it for a circle? The center. So what an ellipse is going to look like is it's going to look like an oval. That's what an ellipse is. Okay, so it's going to be either horizontal, so stretched out right and left, or vertical up and down. Okay. So in this case, our center is 0, 2. Does that make sense? Just like with circles. So you had x minus 0 being squared and y minus 2 being squared. So hk is 0 and 2. All right, my a value is 16, and my b value is 5. Oh, sorry, 4. 4 and 5. All right, this is how much you're going to go like right and left from the center or up and down from the center. All right, so the first thing that you draw is your center, so 0, 2. And then whatever was underneath your x, see how 16 was under the x? That's how far you're going to go right and left. So if I'm under the x, I'm going to go 4 right and left, because it was 4 squared. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, there. And then whatever was under my y is how much I'm going to go up and down. I'm going to say right and left, 4, up and down 5. Okay. Those give me 4 points that allow me to draw in the ellipse. So it's like that. Now technically a lot of books will make the a value the larger value. Like they'll make a 5 and b 4. But I don't want to confuse you, so just remember whatever's under the x is going to be how much you go right and left. Whatever's under the y is how much you go up and down. Okay? All right, so that's the basics of an ellipse. Do you guys think you'd be able to do that on your final? Like draw an ellipse? Yeah. So let's think about it. If I had a bigger number under my x value, so if I had 36 instead of 16, 36 is bigger than 25, right? What would your ellipse look like then? Yep, it'd be wide, right? Allie held her hands out really far on the right and left. Okay, so it'd be wider then. It would be something like this. Okay, so that tells you whether it's horizontal or vertical. So we call this one horizontal, this one vertical. Okay. All right, now it's very similar for a hyperbola. But a hyperbola is going to have a minus in between. So it's going to be like x minus 1 squared minus y plus 2 squared. I'm going to do over 4 and over 16 equals 1. hyperbolas look like this. This one's a horizontal hyperbola. Or this. This one's a vertical. All right, so you go through the same process. First, you need to find what's called the center. Now, the center is just a point that's directly in between those two pieces. It's not actually on the hyperbola, so it's directly between the two pieces. Okay, so I'm going to find the center first. What do you guys think the center is for this hyperbola? 1, and then what? -2. 1, -2. Right, it's always the opposite of what you had. You had x minus 1, so it's positive 1. You had y plus 2, so it's -2. Right, it's always in the form of x minus the h, y minus the k. All right, a is the square root of this first one, so a is 2. B is the square root of the second one, so it's 4. Just like before, if it's underneath an x part, the x minus 1 part, it's telling you how far you're going to go right and left. So right and left, 2. And this one's telling me up and down, 4. Now with hyperbolas, you could switch the x and y values. I mean, they could be flipped. You know, you could have y something squared minus x something squared. Does that make sense? So you still need to remember what is it underneath. Is it under the x value or the y value? Okay, and here's how we draw hyperbolas. It's really not that bad. It's funny looking at first when you first do it. So here's what we do. We draw the center in. So I go over 1, down 2. And just like before, I need to find 4 different points. Okay, so I have a is equal to 2. That was underneath my x, so I'm going to go right and left 2. And then b was 4, and that was under my y, so I'm going to go up and down 4. 1, 2, 3, 4. Okay, that's kind of given me a guide on where my hyperbola is going to go. Okay, what I do is I draw in a box. Okay, so it's just going to be a nice vertical box. You're not going to like connect the dots or anything. Do you guys see how my rectangle is going to go in? You don't connect dots and make like a rhombus or anything. Parallelogram, I guess. You just go straight up and down and hit all of those different dots. Okay, this is going to help us draw it. So you see how you draw in the box? All right, the next thing you do is you draw in the diagonals of the box. So you're going to go through that point in the middle. I kind of missed mine. And through the diagonals of the box. Like that. So now the decision is, do I put my hyperbola, so don't draw this, do I put it like this? Or do I put it like this? So you have a choice. Only one way's right. So what do you think? Any guesses on which way you put it? It has to do with what variable was first, x or y. So if x is first, do you think it's horizontal or vertical? It's horizontal. Okay, if x is first, it's going to be horizontal. So x was first. So it's horizontal. So see how we had like the x chunk first, like x minus something squared. So that means it goes like this. Okay, I don't know why when I was in school I was like, oh, well that one looks like an x. Well, so does the other one. I don't know why I thought that one looked more like an x than the other one. But x is opening horizontal. Okay, you guys think we can handle that? So we're just going to go through these notes and we're going to look for some different examples and we're going to draw the examples. That's really the main thing I want you guys to know. Okay. So number 2, it says graph the ellipse x squared over 16 plus y squared over 25 equals 1. Find the center, the vertices, and the co-vertices. So I'll tell you what those mean. Okay, so when I'm doing this, first I need to find the center. There is no x minus something or y minus something, so what are the numbers? 0, 0. So my center is 0, 0. Okay, a is going to be the number, we'll say underneath x. Like I said, some books will say the bigger number, but we'll just go with this one. So a is the square root of 16, which is 4. B is square root of 25, which is 5. So a is telling me, since it's under the x, it's telling me right and left. B is telling me up and down. They might try to trick you and put the y squared first. Just know that if the y squared is first, the number underneath it's telling you up and down. So we draw it. So we have the center as 0, 0. I'm going to go right and left 4. I'm going to go up and down 5. There's my ellipse. That last part doesn't look very good, but. Okay, so the center we have, the vertices are along the longer axis. So this is one that's stretched up and down, right? It doesn't look like a circle because it's stretched more up and down. So the vertices are along the vertical axis. So this is a vertex, and this is a vertex. And then the co-vertices are the ones that are on the shorter axis. That's called the minor axis, the shorter axis. The larger axis is called the major axis. So this is a co-vertex, and this is a co-vertex. Vertice is just plural for vertex, like the plural form of vertex. Okay, so those are pretty easy to count, right? The vertices, I'll write the plural form. You have one at 0, 1, 2, 3, 4, 5. And 0, 1, 2, 3, 4, -5. And you have co-vertices at 1, 2, 3, 4. So 4, 0. And -4, 0. The last thing you might talk about for an ellipse is called the foci, or foci if you want. And that is basically, there's 2 points that are in the middle. They're somewhere around here. You don't have to draw them. But basically, if you took like a string and you connected the string to the 2 points and then took like a pencil, so let's say this is a pencil or a marker, and you pulled the string tight and you move it all the way around, kind of like, you know how you would do with like a circle? Like you would say, okay, I'm going to do 1 point and I have my circle, and this is my pencil, like a compass. And you bring the pencil all the way around, you create a circle. Well, with an ellipse, if you do that and you pull it all the way around, you create an ellipse. So an ellipse has 2 important points where the circle only had 1 important point. And it's really cool with these foci or foci. Because like in things like the Oval Office, which is a big ellipse, there's actually, like if you stand on 2 spots in that room and you just whisper, I mean this room is huge, but if you just whisper and your friend's on the other spot, then they can hear what you're saying. Because it bounces off the wall in all those different directions. You see what I'm saying? Like it would bounce like here to here, here to here. So if you just barely whisper, then they can hear you. So an ellipse is pretty cool. All right, so let's try another one. So graph the ellipse, x minus 2 squared over 9 plus y minus 3 squared over 4 equals 1. Find the center, vertices, and co-vertices. So the vertices and co-vertices are going to be harder, but if you just count on your grid, you should be fine. So how about you guys go ahead and try this one. All right, so graph the ellipse. So first of all, you guys need to find the center. So what did you guys find for your center? 2, 3. Is Gabby the only one that knows how to find centers, or you guys are just quiet? A is 3, B is 2. So you just take the square root of each one. A is telling you right and left, B is telling you up and down. So we go to 2, 3 and draw our point. I'm going to go right and left 3. I'm going to go up and down 2. So it's a little bitty ellipse. Looks like that. So now where are your vertices? So are they up and down again? No, the vertices now are right and left because that's the longer axis, right? You're just thinking, which way did it stretch? What's the ends of the part that's been stretched from a circle, I guess you could think. Okay, so your vertices are here and here. So from my center, I was at 2, 3. So my height's still 3, but I'm going to go over 3, 4, 5. So it's 5, 3. Like I said, my height's still 3. I'm going to go over 1, 2, 3 from there. So -1. So -1, 3. Did you guys understand that? You just count. All right, and then the co-vertices. Your co-vertices, you were at 2, 3. You go up 2 more. So you're now at 2, 5. And you're at 2, 3. You go down 2. So you're now at 2, 1. And those are your answers.
On our homework, it says like the major and minor axes.
Yeah, if you want to find the length of the major axis, that's just this distance here. So the major axis is going to be 6 units. The minor would be 4 units. You just double these numbers. Right? It's like the length from one vertex to the other vertex.
Oh, okay.
And then the foci, if you guys need to find that, c squared is equal to a squared minus b squared. C tells you how much you go up and down, or how much you go right and left from the center to get those 2 points that I was talking about that are important. You can find those if you want. I won't make you find those. So if you see foci, then go ahead and cross that out. That's probably the hardest part for people. The rest of them are pretty easy. All right, so let's talk about the hyperbola. Okay, so it has 2 axes. So the transverse and the conjugate. The conjugate connects the co-vertices, and the transverse connects the vertices. I remember verse means vertices. So connects vertices. And this connects co-vertices. Okay, that won't be super important. Like I said, the main thing I want you to do for your final is to just be able to draw these. So when you guys do these again in pre-calc, you'll be like, oh yeah, I remember drawing these. These aren't bad. But you'll definitely spend a lot more time in pre-calc. Okay. So let's go ahead and draw this one. So y squared over 49 minus x squared over 9 equals 1. Okay, so first of all, are my hyperbola, is it going to be vertical like this or horizontal like this? So vertical or horizontal? Which came first, x or y? Y. So it's going to be one like this. That's the first thing you need to kind of think about. Okay, so it's going to be vertical. So you're going to have something like that. All right, your center is 0, 0, because there was no y minus something or x minus something. A is 7, B is 3. So when we sketch it out, we start at 0, 0. A was underneath, well, a squared was underneath y squared. So A is telling you up and down, because it was under y. B is telling you right and left. So I'm going to go up 7. 1, 2, 3, 4, 5, 6, 7. Down 7. 1, 2, 3, 4, 5, 6, 7. Those are my 2 points that are going to help me draw in my box. I'm going to go right and left 3. 1, 2, 3. 1, 2, 3. So now I'm ready to draw in the box. And remember, the box is always straight up and down. You're never going to have any like slanty lines or anything. So go straight over, straight down, straight down, straight over. We draw on the diagonals. Once we have the diagonals drawn in, you're good. Because now we know it's vertical, like we said. So we just draw it in. That's it. All right, so the different things that you need to find are the vertices. The vertices are these 2 points, the ones that are on the actual hyperbola, like the bottoms of the hyperbola. Okay, so your vertices were 0, 7, and 0, -7. Your co-vertices aren't actually on the hyperbola. The co-vertices are the points that you didn't have any, like the points on the box that we drew. So they're 3, 0, and -3, 0. And then these ones, they actually have special points as well, which are also called foci. If you wanted to find these points, you would have to do c squared equals a squared plus b squared, like the Pythagorean theorem. All right, I always remember in my hyperbola equation I had a minus, so it's c is plus. In the ellipse I had a plus in my formula, so it's c is minus. Okay, like I said, I'm not going to make you guys find the foci. So if you guys need to, or if you have that in your homework, just skip it. The main thing I'm concerned with is that you know how to draw. Okay? Okay, let's try maybe 1 or 2 more. All right, so try to draw 1 and 2. So let's see. So my center for number 1 is 3, -5. Do you guys see it? A is 3, B is 7. So I draw my center in. So 3, -5. Is A telling me up and down or right and left? Right and left because it's underneath the x value, so it's right and left. B is telling you up and down. So from my center, I'm going to go right and left 3. I'm going to go up and down 7. So as you're doing this, it might be helpful to kind of think about what these points are as you're drawing them. So as I went right and left 3, are those going to be my vertices or my co-vertices? Kind of a tricky one. It's okay if you have to draw it in first.
What was the question?
Are they going to be my co-vertices or my vertices, the first 2 points I drew in? The ones that were right and left? They're going to be the vertices because it's the x, right, that came first. So since x came first, it's looking like this. So they're going to be the vertices. So if you want to keep track as you go, it might help because, you know, as you're counting over, you're like, oh, I was at 3, now I'm at 6. So that is the point 6, -5. And I was at 3 before, and I counted over 3, so I'm at 0, -5. Those are my vertices. My co-vertices, my center was 3, -5, and I went up 7. So what am I at now? 3, 2, right? You added 7 to your y value. You went up 7. And then you go 3. So I was at 3, -5, and I subtract 7 down. So I'm at 3, -12, right? Draw in your diagonals. These are called asymptotes. You can find the equations of those if you want. I mean, it's just the equation of a line. You can find where it crosses the y-axis and everything. That's another one I won't make you do. So you can cross out asymptotes and then the foci as well. All right, and then it opens in the x direction, so it's going to go right along that asymptote like this. So you don't ever go inside the box. You just stay right on the outside and then along those diagonal lines, and that's it. Is this making sense? You guys think you can do it on your own? Okay, let me look throughout your homework and let you know if you don't have to do anything. So.